Double-ended queue. Decay or double-ended queue is a type of queue in which insertion and removal of elements can either be performed from the front or the rear. Thus, it does not follow rule first in, first out. Types of decay. Input restricted decay. In this decay, input is restricted at a single end but allows deletion at both the ends. Output restricted decay. In this decay, output is restricted at a single end but allows insertion at both the ends. Operations on a decay. Below is the circular array implementation of decay. In a circular array, if the array is full, we start from the beginning. But in a linear array implementation, if the array is full, no more elements can be inserted. In each of the operations below, if the array is full, overflow message is thrown. Before performing the following operations, these steps are followed. Take an array, a decay of size n, set 2 pointers at the first position and set front equals to -1 and rear equals to 0. Insert at the front. This operation adds an element at the front. Check the position of front. If front is less than 1, reinitialize front to n-1, which is the last index. Else, decrease front by 1. Add the new key 5 into array front. Insert at the rear. This operation adds an element to the rear. Check if the array is full. If the decay is full, reinitialize rear to 0. Else, increase rear by 1. Now, add the new key 5 into array rear. Delete from the front. The operation deletes an element from the front. Check if the decay is empty. If the decay is empty, which means if the front is equals to -1, deletion cannot be performed. This is the underflow condition. If the decay has only one element, which means if front is equals to rear, set front to -1 and rear to -1. Else if front is at the end, which means if front is equals to n-1, set go to the front equals to 0. Else, front equals to front plus 1. Delete from the rear. This operation deletes an element from the rear. Check if the decay is empty. If the decay is empty, which means if front is equals to -1, deletion cannot be performed. This is the underflow condition. If the decay has only one element, which means if the front is equals to rear, set front as -1 and rear as -1. Else follow the steps below. If rear is at the front, which means if the rear is 0, set go to the front rear as n-1. Else, rear equals to rear -1. Check empty. This operation checks if the decay is empty. If front equals to -1, the decay is empty. Check full. This operation checks if the decay is full. If front equals to 0 and rear equals to n-1 or front equals to rear plus 1, the decay is full. Time complexity. The time complexity of all the above operations is constant, which means big O of 1. Applications of decay data structure. In undo operations on software, to store history in browsers, for implementing both stacks and queues,